Probabilistic versus non-probabilistic classifiers. In the last few lectures, when we discussed about loss functions and all, we mentioned at some places that these loss functions are applicable for probabilistic classifiers and these ones are not. In those cases, you would have thought what exactly are these probabilistic classifiers and what are non-probabilistic classifiers. So here we are going to clarify on that what exactly are probabilistic classifiers and what are non-probabilistic classifiers. And most importantly, when should you make use of a probabilistic classifier and when should you make use of a non-probabilistic classifier. Let us understand this. First of all, what is a probabilistic classifier? As the name suggests, what you have to understand here is a probabilistic classifier always outputs class probabilities, that is probability of y given x. So when I say class probabilities, it will give something like this: probability of y is equal to 1 given x, that is the probability that this particular example belongs to class 1. If you remember our logistic regression lecture, though we had seen that probability of y equal to 1 given x, this was find out like something like this: sigma of w transpose x plus b, and from this we found out what is the probability that x belongs to class 1. Using that, what did we do? How did we decide on the class? In order to decide on the class, we told class y cap, it will be based on this, that is, it will be class 1 if my probability of y equal to 1 given x, we are considering just binary classification here. If this is greater than 0.5, I'll say it belongs to class 1, and otherwise if it is less than 1, if probability of y equal to 1 given x, if this is less than 0.5, I'll say it belongs to class 0. So this is how we implemented the classifier. Whenever you want a classifier, finally you want to know which class it belongs. That is the logic. But how are you reaching there? That is where probabilistic and non-probabilistic differ. In case of a probabilistic classifier, what you do is you will explicitly look for the probabilities, which also means the classifier can tell you exactly how likely is this prediction going to be true, or how likely is this particular class the right answer for this particular example. So if you see it is a multi-class classification, then what will a probabilistic classifier do? If you have different classes 1, 2, 3 and 4, then it will tell you that according to me for this particular example, the probability that it belongs to class 1 is maybe 0.1. For class 2, it is 0.1. Class 3, it is 0.6. And class 4, it is 0.2. From this, what are you going to do? You are going to choose that class which is having highest probability as the class for this particular example. This is how you are doing classification in case of a probabilistic classifier. You will find probability for each class. Then whichever class is having highest probability, you will say this is the class to which this particular example belongs. The loss functions that you use here, we had seen the loss function of cross entropy or maybe KL divergence. These are used in probabilistic classifiers. Okay. What are the examples of probabilistic classifiers? You have many, like maybe logistic regression, we already said. Then your neural networks generally follow probabilistic method, or maybe a naive Bayes method. All these are probabilistic classifiers. So then automatically the question that comes to your mind is, what then is a non-probabilistic classifier? You are finding probabilities, then you are finding the class. Then what does a non-probabilistic classifier do? So when it is a non-probabilistic, what it does is, this time it is no more concerned about probabilities. It is not going to find out how probable is any class. It is simply going to use let us say a discriminant function or maybe a decision boundary. By using some technique, it just want to separate between classes. It will say this is class 1, this is class 2, but I don't know how likely each example is. I simply know that it belongs to class 1 or it belongs to class 2. This is what a non-probabilistic classifier does. So generally what you do in a non-probabilistic is, instead of this approach which we explain for probabilistic, in non-probabilistic what happens is, it will have a, let us say, discriminant function or something. You will have a function f of x. Let us say this is w transpose x plus b. If this is the case, so I'm taking example of something like SVM. So perceptrons, SVMs, all these are non-probabilistic classifiers. If I'm taking SVM, then you will have a function w transpose x plus b. Then how will you decide on the class? This time you don't have any probability. You just have this score f of x. Then you will say my y cap, this will be the sign of w transpose x plus b, which means if the value of w transpose x plus b, that is if the value of f of x, if this is greater than 0, then I will say it is class 1. If the value of f of x is less than 0, then I'll say it is class 2. This is what I am going to do in a non-probabilistic classifier. Now you can have a doubt. You can say previously you told that for each class there is a value which is probability. Here also you have a value, you have a function, you have a value, and based on that value only you are saying which class it is. But the point here is, this value is not a probability. Still you can think it still has a magnitude. That is, if I'm saying greater than 0 is class 1 and less than 0 is class 2, then automatically if it is very largely positive, that means there is a high probability that this is positive, that is class 1 itself. And if it is very negative, then you can say confidently this is negative. That is true. But the point is, this magnitude, it is not a calibrated probability. It is simply a magnitude which can be a distance from margin or something like that. So this is the difference between probabilistic and non-probabilistic. Here you don't have an estimate of probability. You don't know how exactly likely is each class. You just know that you have a decision boundary, and on one side you have class 1, other side you have class 2. Or maybe you have a discriminant function. From that function you can simply say it is class 1 or class 2. You can't say that this much probable is this class, this much probable is this class. That is not possible in a non-probabilistic classifier. One more thing, when I previously talked about probabilistic classifier, I think I should mention this as well. Inside probabilistic itself, you have two types of classifiers. So one is generative and the other is discriminative. The reason I am explaining this is coming out of the core of how you find that P of y given x. In probabilistic classifiers, I already explained, you have to find out P of y given x, and from this you will be identifying which is the class. So I'm explaining about these two types of probabilistic classifiers because generative and discriminative models, they are based on how are you going to find this. So that is important. So from the base formula, you know that P of y given x, this can be found out as P of x given y into P of y whole divided by P of x. This you already know, this is base formula. What a generative model does is, for example, naive Bayes classifier is a generative classifier. It is a generative probabilistic classifier. Coming to generative models, what they do is, they will find out this P of x given y into P of y. And using this, it will find out P of y given x. That is why it is called as generative. So this is the difference. Mathematically, it is first going to find out this, and using this base formula, it will be able to identify P of y given x. But when it is a discriminative model, what it does is, it does not even get concerned about these things. It directly finds out P of y given x. This is when you call it a discriminative model. For example, Logistic regression is a discriminative model. Okay, generally when you use a neural network, it will be a discriminative model, but naive Bayes is generative model because it is going to find out p of x given y into p of y. From that it is going to find out p of y given x. So that is the difference between generative and discriminative. So these are all class of probabilistic classifiers. Non-probabilistic we already explained. One more thing before we conclude this lecture, because we discussed about probabilistic and non-probabilistic, you should also know when should you use probabilistic and when should you use non-probabilistic. The answer is whenever you are in a situation where you want a model and with that you just need accurate decision boundary, that is you simply want to know it is class 1 or class 2, then you better go for non-probabilistic classifier. But if you need the confidence or uncertainty estimates, then that is if you want the probabilities of each class, then you should go for probabilistic classifier. So this is the case, and this is the difference between probabilistic and non-probabilistic classifiers.